Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. In today's video we are going to discuss about analysis, truss analysis, method of section, truss. A truss is a structure that consists of two force members only, where the members are organized so that it behaves as a single object. For example, while traveling in a train you might have crossed over railway bridges. If you have noticed properly, those bridges are nothing but an assemblage of iron sections joined together in horizontal, inclined or vertical fashion. These sections, or here we will term it as members, are nothing but truss members. These truss members help in distributing the entire load safely. There are two basic techniques for analyzing statically determinate trusses. Method of joints. Method of sections. Generally speaking, the method of joint is preferred when the entire truss is to be analyzed. When all the member forces are to be calculated. We have discussed about method of joint in another video earlier. The method of sections. The method of sections is a process used to solve for the unknown forces acting on members of a truss. The method involves breaking the truss down into individual sections and analyzing each section as a separate rigid body. The method of sections is usually the fastest and easiest way to determine the unknown forces acting in a specific member of the truss. If the forces in only a few members of a truss are to be determined, the method of sections is generally the most appropriate analysis procedure. The method of sections consists of passing an imaginary line through the truss, cutting it into sections. Each imaginary section must be in equilibrium if the entire truss is in equilibrium. Summation F x equals 0. Summation F y equals 0. Summation M z equals 0. Using the method of sections. The process used in the method of sections is outlined below. In the beginning, it is usually useful to label the members in your truss. This will help you keep everything organized and consistent in later analysis. In this video, the members will be labeled with letters. Treating the entire truss structure as a rigid body, draw a free body diagram. Write out the equilibrium equations, and solve for the external reacting forces acting on the truss structure. This analysis should not differ from the analysis of a single rigid body. Next, you will imagine cutting your truss into two separate sections. The cut should travel through the member that you are trying to solve for the forces in, and should cut through as few members as possible. The cut does not need to be a straight line. Next, you will draw a free body diagram for either one, or both sections that you created. Be sure to include all the forces acting on each section. Any external reaction or load forces that may be acting at the section. An internal force in each member that was cut when splitting the truss into sections. Remember that for a two-force member, the force will be acting along the line between the two connection points on the member. We will also need to guess if it will be a tensile or a compressive force. An incorrect guess now though will simply lead to a negative solution later on. A common strategy then is to assume all forces are tensile, then later in the solution any positive forces will be tensile forces and any negative forces will be compressive forces. Label each force in the diagram. Include any known magnitudes and directions and provide variable names for each unknown. Write out the equilibrium equations for each section you drew a free body diagram of. These will be extended bodies, so you will need to write out the force and the moment equations. For 2D problems you will have 3 possible equations for each section, 2 force equations and 1 moment equation. Summation F x equals 0. Summation F y equals 0. Summation M Z equals 0. For 3D problems you will have 6 possible equations for each section, 3 force equations and 3 moment equations. Summation F equals 0. Summation F x equals 0. Summation F y equals 0. Summation F z equals 0. Summation F equals 0. Summation Fx equals 0. Summation phi equals 0. Summation Fz equals 0. Finally, solve the equilibrium equations for the unknowns. You can do this algebraically, solving for one variable at a time, or you can use matrix equations to solve for everything at once. If you assumed that all forces were tensile earlier, remember that negative answers indicate compressive forces in the members. Method of section. It provides a quick way for calculating the force in a few members only. This method is based on the principle that when a structure is in state of equilibrium, every substructure within it must also be in equilibrium. For example, this truss is in the state of equilibrium. If we cut it like as shown in the figure below, then the left substructure and the right substructure must be in equilibrium. Needless to say, such a cut is imaginary, done on paper for the purpose of analyzing the truss, only naturally the actual truss members need to remain intact, if the structure is to carry the intended load. This method of cutting a structure into parts is a convenient way for determining some of the unknown member forces without needing to analyze the entire truss. More specifically, the method enables us to rather quickly calculate the force in one or more cut truss members. In this particular truss, we can determine the force in members member BD, member BE, member CE, without needing to analyze the entire structure. Generally, we may be able to cut a truss in several ways. The challenge in using the method of section is to identify an effective way to cut the truss, and then decide how to use the equilibrium equations to find the desired unknown forces. Let us go through the examples. Example 1. See the figure to know about the truss. Now, finding the steps involved in the method of section, here is a statically determinate truss subjected to two concentrated loads. The truss rests on areolar support at point A and a pin support at point H. Now, we have to determine the forces in member BD, CE. First, we need to calculate the support reactions. To do so, we are going to write the equilibrium equations for the entire structure. Here are the equations. We have 3 equations and 3 unknowns. A, Y and H. Y minus 4 equals 0. Equation 1. H x plus 3 equals 0. Equation 2. 20a y plus 15 minus 20 equals 0. Equation 3. On solving these equations for unknown reactions, from equation 3, 20a y equals 5 a y equals 5/20a y equals 0.25 kilonewton. From equation 2, H x equals minus 3 kilonewton. From equation 1, 0.25 plus high equals 4h. Y equals 4 minus 0.25h. Y equals 3.75 kilonewton. Now, to find the force in member BD, we need to cut the structure through the member. The most suitable cut is one that passes through member BD, BE and CE. Since the cut goes through BD and CE, we can calculate both member forces using the same set of equation. When we cut a truss into 2 parts, we must show the internal axial force in each cut member in the free body diagram. Here, Since we have cut through member BD, BE and CE, we need to show the axial force for each of these members in both the left and the right substructures. So for the left substructure the forces are drawn, as shown in figure. For the right substructure, the forces are drawn, as shown in the figure below. For purpose of consistency, we assume that all the members are in tension, therefore, the axial force associated with each cut member is drawn point away from the joint connected to the member. We can determine these unknown members' forces by applying the equilibrium equation to either the left free body diagram or right free body diagram. Let us use left free body diagram to calculate. Here we will write three equilibrium equations. For sum of the forces in x direction 3 plus F, BD and F, CE plus F, BC cos 45 degree, equals 0. Equation 1. For sum of the forces in y direction 0.25 minus F, BC sin 45 degree, equals 0. Equation 2. For the sum of the moment, say about point B, assuming clockwise direction as positive, we have 0.25 times 5F. CE times 5 equals 0. Equation 3. Solving these equations for unknowns, from equation 3, F, CE equals 0.25 times 5, / 5 equals 0.25 kilonewton. From equation 2, 0.25 equals F, BC sin 45 degree, F, BC equals 0.25 / sin 45 degree equals 0.35 kilonewton. From equation 1, 3 plus F, BD plus 0.25 plus 0.35 cos 45 degree equals 0, F, BD equals 3.5 kilonewton. Summary. In this truss structure, member CE carries a tensile force of 0.25 kilonewton. Member BE carries a tensile force of 0.35 kilonewton. Member BD carries a compressive force of 3.5 kilonewton. Thank you for watching. Solved problem related to method of section will be discussed in another video of truss analysis, method of section. For now, please subscribe, like, share and do not forget to press bell icon.